Alright, in this video I'm gonna walk through the steps to solving the problems on your quadratic function worksheet. Problem 1 on the screen is very similar to the first 6 problems that you have to do for your assignment tonight. It's also similar to the first question that you're going to see on tomorrow's quiz. Looking at the directions, the first thing that you're asked to do is to identify the vertex. Identify the vertex. On the top of the paper, I wrote the generic form for the equation of a quadratic function, and you'll notice that the vertex point comes from h and k. H is the number in the house with the x, and k is the number that's being added or subtracted on the outside. And then remember that h's character flaw is that he's a rebel child, which means we're always going to think opposite with h. On the other hand, K, he's the cool kid that goes with the flow. With him, what you see is what you get. So for our problem here, you can see that the number inside the parentheses with x is a +1, and then the number that's being added or subtracted on the outside is that -4. That means that the vertex for our problem is the ordered pair -1, -4. Okay, I do want to see that you write the ordered pair on your paper. After you find the ordered pair, then you're going to create a table. Okay, X will be on the left column and Y will be on the right. Now remember, the vertex lives in the center of our parabola, so we're going to put it at the center of the table. So -1 is going to go in the X column, and -4 is going to go right next to it in the right side. Once you have that, now we're going to finish the X column by stacking 5 numbers that are in a row where -1 is in the middle. Okay, so I get -2, -3, 0, and 1. Okay, now that our table is set up, we need to find the 4 remaining y values, and that's done by evaluating our equation for the value in x in each row. The number we get out in a calculator will tell us the y side of that row. So for the first row, we're going to evaluate f of -3, which means we're going to write our equation out, and we're going to replace x with -3, and we're going to solve this. Okay, so over on the left side, I'm going to type this into the calculator. I'm going to get -2, parenthesis, -3 plus 1, close the parenthesis, squared, -4. And I get -12 for this problem. Okay, so that means I'm going to write -12 in the table. And then I'm going to evaluate the next number, f of -2. So we get -2, parenthesis, -2 again, plus 1 this time, squared, -4. And I'm going to evaluate that in a calculator. So I get -2, parenthesis, -2 plus 1, close the parenthesis, x squared, -4. And we get -6 this time. Okay, we can skip the center row because we already have the -4 on the y side, and then we go to do f of 0. -2, parenthesis, 0 plus 1 squared, -4. And then I type that in the calculator, 0 plus 1, parenthesis, x squared, -4, and I get -6 again. And then the last one, f of 1, replacing x with 1 in the equation, And then calculating, we get -2 parentheses 1 plus squared minus 4. And that's -12. Now remember, the graph of a quadratic function is that parabola, which is symmetrical in its shape, which means that the fact that the y values seem to have repeated should make sense. Okay? So once we have a complete table, we're going to graph as many points as we can. And looking at this, I can tell that I don't have y values that go all the way down to -1. Or -12, excuse me. I have -8 as my lowest number. So even though I put these on the table, I'm not going to use them on the graph. I'm going to use the middle 3 only. Okay, so I get -2, -6. -1, -4. And 0, -6. Once you have your 3 points, which should look like a triangle, I'm going to start with the vertex point, which is the -1, -4, and I'm going to draw my U shape through the other 2 points, putting arrows on the ends of my lines. Okay? Sometimes your parabola will look like it's going in the other direction, where the arrows are pointing up. That's okay. Remember, this a value that's at the front of our equation, in this case it's -2, that tells us the mood of the graph. Remember, if a is positive, our graph is going to be happy and it's going to look like a happy face. But in this case, a is negative, which makes our happy face look like a sad face. That is a perfect example of problem 1. So I'm looking for you to tell me the vertex, set up a table, evaluate that table, making sure you show all your work, and then graph your line, graph your parabola. Okay, I'm looking for the arrows specifically, and I am looking to see that the dots are graphed on the plane. Okay, check out the other video to see the example number 2 on this page. Good luck!